Hello, Algebra 2 students. Today we are going to begin a unit on exponents and radicals. And so our first lesson is just some of the basic rules dealing with exponents and radicals. You'll be asked to simplify some expressions, and when you simplify expressions, your final answer will make sure that each base appears exactly once. So for example, here the base of 7 appears twice, so we know it's not done. There are no powers of powers in your final answer. For example, here number 9, this is a power of a power, so you know that's also not done. All fractions are reduced. So for example, if you had the fraction 3/6, it would reduce to 1/2. And there are no parentheses or negative exponents in your final answer. So as you go through some of these examples, especially the more complicated ones at the end, if you're wondering if you're done, you can go back to these rules and see if you have followed all those rules. So these rules for exponents, they all come from a place that makes sense, and we will look at those places as we go through them. So the multiplication rule says when you multiply two powers with the same base, then you add their exponents. And let's just think about why that is. Using the multiplication rule here, I can predict that x to the 6 times x to the 3 would be x to the 6 plus 3, which is x to the 9th. And let's see why that works. X to the 6 literally means x times itself 6 times. So there are 6 x's. 1, 2, 3, 4, 5, 6. That's x to the 6 times x to the 3, which is x times x times x. Right? Now, when I put all this together, I have 9 x's, right? I add the 6 from this one to the 3 from this one. And this is why we add 6 plus 3. So when I add the 6 from this one plus the 3 from this one, I get x to the 9th. All right, and that works too when I have variables in my exponent. So here my base is 7, so I'm going to keep my base to be 7. Do not multiply the bases. In this case here, I didn't multiply the x times x to make x squared. You keep your base as 7, and then you add your exponent. So I'm going to add x plus 2y. Now these are not like terms, so I can't actually combine them into one, but I have expressed that I'm adding x plus 2y. So this is my final answer, 7 raised to the exponent x plus 2y. All right, here again, my base is x, it's the same base, so when I multiply, I'm going to add my exponents. So keep your base as x, and then add your exponents. All right, I do have some like terms I can combine here. So my final answer will be x to the y plus 6. All right, so for the division rule, you might have predicted, since when we multiply, we add exponents, when we divide, we subtract exponents, and of course only if they have the same base. Let's look at this example here, number 5. So remember, x to the 5th would be x times itself 5 times, and x squared is x times itself just twice, so 2 x's as factors. And then remember that division and multiplication are inverse operations. They can undo each other. Division and multiplication can undo each other. So when I divide, I can cancel these out, leaving me with this, which is x to the 3. So it does work to subtract, because what you can think of it as is, here I have 5 on the top, here I have 2 on the bottom. I can subtract these 2 out, which is the canceling out, and I'm left with these 3 here. So I can do it, of course, without writing it out. I can just say, okay, it's x to the 5 minus 2, which gives me the x to the 3. All right, here, my base is the same, it's 3, so I can subtract my exponents. Do not multiply the bases, do not divide the bases. The base stays 3, just like the base here stayed x, and you subtract your exponents, x minus 2. They're not like terms, I can't combine them, but I can leave it as the expression 3 to the x minus 2. All right, and then let's look at the last one over here, m. You should try this one. Pause the video and try it before actually listening in. All right, so you should have subtracted, of course. Keep your base as m. The numerator has the exponent 2x plus 4, and then you subtract the exponent in the denominator. I have some like terms I can combine, so I have m to the 2x plus 1. All right, try the practice problems below before listening to the answers. Okay, so same base, so I can use my multiplication rule. This one, I can't see the exponent, but I know that 2 is the same as 2 to the first power. So I'm going to add the exponents and get 2x plus 1. This is a division, so I'll use my division rule and I'll subtract the exponents. 6 to the 8x minus 1, and then minus 2x. Combine my like terms, 6 to the 6x minus 1. All right, and I don't have an exponent rule yet, so what I'm going to do is make this a multiplication problem. So when I square something, it means to multiply it by itself, so I'm going to do y to the 3 times y to the 3. Now I can apply my multiplication rule that says I'm going to add my exponents, so I get y to the 3 plus 3, which is y to the 6. All right, and some of you may have looked ahead to find that power rule to figure out how to do number 9, because this problem can also be done with the power rule. The power rule says when you have a to the x to the y, you can multiply those exponents. So 3 times 2 gives you the 6 here. 2 ways to think about the same problem. All right, so again, with this problem down here, I could write this out. When I raise something to the third power, it means to multiply it 3 times. So I could write m to the 5 times m to the 5 times m to the 5 and use my multiplication rule from up here. Or I can use my brand new power rule that says to multiply the exponents. So 5 times 3 would give me 15. When you have two things in your parentheses and they are being multiplied together, you can still apply the power of a power rule. Just remember that the 2 here without an exponent is 2 to the 1. And so I'm going to take the base 2 and multiply my exponents. Take the base x and multiply my exponents. Okay, 2 to the 4 is 2 times 2 times 2 times 2, which is 16. And x to the 28. All right, you should try this next one on your own before listening. So you could give each of these a 1 if you wanted, and then remember to multiply your exponents. So 1 times 2 is 2, 1 times 2 is 2. Or you could have just squared each part. And then you're going to simplify 6 squared to be 36. So x squared over 36. All right, moving on. Oops. Find it over here. All right, a 0 exponent always gives you an answer of 1. A negative exponent will give you the reciprocal. So notice when you have a negative exponent, you want to give the reciprocal of that, and then it changes to positive. And if you have a fraction exponent, that is referring, the numerator is an exponent, the denominator is the index of your radical here. And we'll talk more about radicals in an upcoming lesson. All right, so here the 0 is on the outside, so that means that anything in here raised to the 0 power gives me an answer of 1. This negative exponent here is going to go to the denominator and become a positive exponent. And then this m to the 5/6, I'm going to rewrite that as a radical. So it's going to be the 6th root of m to the 5th. Or you could also put the 6th root first, and then you could put to the 5th on the outside. They're both the same. All right, so I would like you to challenge yourself with some of these putting it all together problems. Pause the video and then come back and see. If you get stuck, you could listen to 1 or 2 of them and then go back and try some more on your own. Okay, so here we go. There is no only one way to start these. I like to multiply across first and then divide. So when I multiply across, I have 2, but the x's have the same base, so I'm going to add the exponents, and I've got y to the 1. In the denominator, I have 4, y to the 3. All right, 2 over 4, those coefficients act like a normal fraction, and that's going to simplify to 1/2. The x to the 3 has nothing to combine with, so it's going to stay there. Now, when you subtract, you could subtract 1 minus 3 and get y to the negative 2. And then that y to the negative 2 will end up in your denominator. I just realized up here that I forgot to make that a positive 9 when I put it up there. Sorry about that. Okay, there we go. And so that could jump down there and become y to the positive 2. Or you could do the larger minus the smaller, 3 minus 2, 1, 3 minus 1, and then you put your answer where the larger is. So 3 minus 1, and then that would be y squared. No matter how you do it, just remember it's not as complicated as it seems. Y to the 3rd is y times y times y. Y to the 1 is y. And so those two will cancel out, giving you y squared in your denominator. Okay, I think most people like to think of this as 1 minus 3, giving you y to the negative 2. And then 1x to the 3 is just x to the 3. And your y to the negative 2 becomes y to the positive 2 in the denominator. All right. Next one, number 17, I'm going to multiply across first. So negative 2 times 2 is negative 4. When I multiply the x's, I add their exponents, and I get x to the positive 1. 3, x to the 1. And when I multiply the y's, I add the exponents, and I get y to the 2. So the x to the 1's cancel completely out, giving me negative 4 in my numerator, 3y squared in my denominator. All right. Number 18, some people like to distribute this 3 first, and some people like to simplify first. I'm going to simplify first. So inside here, I've got 2. That's my only coefficient. I have more x's in the bottom, so what I can do is I can subtract 2 minus negative 1 and put the x's in the denominator. That would give me 3. So I would have x to the 3 in the denominator. For the y's, I have 5 minus negative 4, which is 9. And I have more y's on the top, so my y to the 9 goes in the numerator. And I've dealt with the 2, the x's, and the y's, so I just need this 3 out here. Then everything is raised to the 3rd power, 2 to the 3rd power. Here I'm going to multiply my exponents, 9 times 3 to get 27, and 3 times 3 to get 9, x to the 9. All right, and then 2 to the 3rd is 2 times 2 times 2, which is 8, y to the 27 over x to the 9. All right, down here, I cannot multiply these as long as I have this exponent on the outside, so I have to deal with that first. So it's going to multiply to all of these. Remember, if they don't have an exponent, you can put a 1 on them. So I have 5 to the 1 times 3, a to the 1 times 3, b to the 2 times 3, and c to the negative 4 times 3, so c to the negative 12. 15, a to the 4, b to the negative 1. All right. So I need to multiply 5 to the 3rd times 15, and I'm probably going to need a calculator for that. So I'm going to multiply 5 to the 3rd. That gives me 125, and then 125 times 15. Okay, so 1,875. When I multiply the a's, I add the exponents. I get a to the 7, b to the 5, 6 plus negative 1, c to the negative 12, and then the c part will have to go to the denominator. I don't have a fraction yet, but I'm going to make one. 1,875, a to the 7, b to the 5, over c to the 12. Okay, this one here, I'm going to multiply across. So 12 times 2 is 24. Add my exponents, x to the negative 2, y to the 7. 48. Add my exponents, I have x to the 4, y to the 5. All right, 24 over 48 is a fraction. If I divide them both by 24, I get the fraction 1/2. I have more x's in the denominator, so I'm going to subtract 4 minus negative 2 to get 6, and I have x to the 6 in the denominator. And then 7 minus 5 gives me y squared in the numerator. Now you can keep the 1 there, or you can just write y squared over 2x to the 6. All right, in our next lesson, we're going to have a lot of fractions as exponents, so we just need to review how to deal with fractions. All right, so just a little review of fraction rules. You can simplify a fraction by dividing the numerator and denominator by the greatest common factor. So for example here, 35 over 42 have a greatest common factor of 7. So divide them both by 7, and I'm going to get 5/6. Try this one. You should divide them both by the greatest common factor of 6, and you'll get 1/5. To add and subtract fractions, convert to a common denominator, and then you add or subtract the numerators. So these already have a common denominator, so I'm just going to add the numerators to get 5 over 13. These do not have a common denominator, so I can get a common denominator of 21 by multiplying the first fraction by 3 over 3. You're allowed to multiply by 3 over 3 because you're essentially multiplying by 1. 3 divided by 3 is 1, which does not change your fraction. So I have 12 over 21 minus 2 over 21, and I end with 10 over 21. All right, to multiply fractions, you just multiply the numerators and you multiply denominators. So in this case, I have 6 over 20. That can be simplified by dividing by 2. So I get 3 over 10. Another way to simplify is if something cancels in the numerator and the denominator, you can just simplify right away. And in this case, I would just get 1/3.